Welcome back to the Explainer Focus Learners. Today we're taking a really fascinating, behind-the-walls spatial tour of the life-saving nervous system inside modern buildings. I mean, we walk through these structures every single day, right? Apartments, office blocks, shopping centers, but we rarely stop to think about the incredible engineering that keeps them safe. Well, we're going to unlock a very specific and honestly a very critical part of the AS/NZS 3000-2018 wiring rules. This is the rulebook that governs electrical installations across Australia and New Zealand. And today, we're zeroing right in on Section 7. Because this isn't just about making sure your lights turn on, it's about how a building behaves when absolutely everything goes wrong. So I want to hook you immediately with a high-stakes scenario. Imagine a disaster. A massive building catches fire. The very first thing that usually happens, whether it's from the damage itself or a deliberate safety protocol, is that the main power is cut. The lights go out. The normal circuits just die. So ask yourself, in that exact moment of chaos, when the grid goes dark, how do those massive fire sprinkler pumps keep running? How do the evacuation systems keep operating and the alarms keep sounding? Well, the punchy answer to that question is Section 7 of the wiring rules, Special Electrical Installations. We're way beyond your standard living room wiring here. This section of the codebook acts as a literal invisible shield. It dictates exactly how these extreme, high-stakes electrical systems must be designed, segregated, and protected, so they act as an unbreakable lifeline when we need them the absolute most. Okay, let's dive into the first stop on our tour, safety services under fire. We're starting at the heart of the building's emergency lifelines. According to Clause 1.4.10.4, a safety service is any system that operates to identify an emergency, evacuate people, or fight fires. We are talking about some serious, heavy-duty infrastructure here. This includes fire hydrant booster pumps that push massive amounts of water through a building, smoke control fans that keep the stairwells clear of toxic air, and emergency lifts designed specifically for firefighters to use when every other elevator is grounded. The code recognizes a fundamental truth. These systems simply cannot be allowed to fail just because a standard electrical circuit tripped somewhere else in the building. So how does the code actually guarantee they survive? Notice the strict hierarchy of protection demanded here. First up, it requires a physical separation of at least 50 millimeters horizontally from all other wiring systems. So if there's a fault in your office lighting, it physically can't jump over and take out the fire pump. Second, the code mandates fire-resistant enclosures for these lifelines. And third, it requires what are known as WS classification cables. These are highly specialized cables designed to literally sit inside a burning room, endure extreme mechanical damage, and still continue to deliver electrical current to the safety services. They are, for all intents and purposes, armored against the apocalypse. And this brings us to a brilliantly human element of the code. Clause 7.24.4 requires this exact, highly visible red label to be placed on the main switches controlling these lifelines. In the event of fire, do not switch off. Think about it. When a building goes into emergency mode, it purposefully sheds non-essential electrical loads. It kills power to normal outlets and everyday lights to prevent further electrical fires and conserve energy. But it routes all of its survival energy precisely to these switches. The code actually designs the switchboards so that panicked occupants, or even the firefighters themselves, don't accidentally plunge the building's defense systems into darkness. Moving our tour right along, let's look at modern power and what I like to call the grid on the roof. So we're moving from the emergency stairwells all the way up to the roof to see how the code handles a massive shift in modern infrastructure. Basically, homes are now decentralized power plants. Clause 7.3.1 governs a really diverse range of alternative power sources under electricity generation systems. We're talking solar PV inverter systems turning sunlight into alternating current, massive lithium battery systems storing that power, traditional engine-driven generators, and even completely standalone power systems for remote areas. Now, because these systems actually create or store massive amounts of power on site, the rules for installing them have to be incredibly strict so they don't conflict with the main electrical grid. I really want to draw your attention to this brilliant rule from Clause 7.3.3. It states that an electricity generation system shall be so arranged that it cannot supply energy upstream, either directly or indirectly. Basically, unless you have a specific formal agreement with the utility company for cogeneration, your system absolutely cannot backfeed. Why does this matter so much? Well, imagine a massive storm knocks out power to your neighborhood. Utility workers climb the poles to fix the dead wires. If your house's solar panels or battery system silently pumps electricity backward into that dead grid, those wires suddenly become live, and it could instantly electrocute the workers. Section 7 ensures that when the grid dies, your personal power plant instantly severs its connection to the outside world. To enforce this, the code strictly requires an independent, manually controlled isolation switch for these generation systems. And what's really fascinating here is what the code explicitly forbids. Under Clause 7.3.4.1, this isolation switch absolutely cannot be overridden or bypassed by programmable control systems. You cannot rely on a smart home app or a piece of software to isolate a massive battery bank or a solar array. It must be a physical, manual switch that a human being can lock out, ensuring total safety when maintenance is happening. Because, let's face it, software can glitch, a heavy-duty mechanical breaker doesn't.
Let's shift gears now and head into Section 3, the voltage extremes.
Taking our spatial tour from the roof all the way down to the wet areas, think a backyard pool or a decorative fountain, the code relies on really rigid mathematical thresholds to define what is actually safe to touch. We can clearly see where the code draws the line for what it calls extra low voltage, or ELV. For alternating current, which is the kind that comes right out of your wall sockets, the maximum limit to be considered extra low voltage is just 50 volts. For direct current, like from a battery, it's 120 volts ripple-free. Essentially, anything below these numbers is generally considered safe enough that a healthy human body won't suffer a lethal shock if they accidentally touch a live wire under normal, dry conditions.
But notice how engineers handle these safe voltages based on their relationship with the literal ground beneath our feet. The code divides extra low voltage into two highly technical but totally crucial categories: SELV and PELV. SELV stands for separated extra low voltage. The keyword here is separated. The circuit is electrically isolated from Earth. This means that even if a single fault happens, the electricity has no pathway to use your body to get to the ground, which prevents an electric shock. PELV, on the other hand, stands for protected extra low voltage. It is not separated from Earth. It intentionally uses a ground connection for equipment function, but it still requires the exact same strict voltage limits and insulation standards as SELV to make sure you stay safe.
Now let's see how this builds when we apply these concepts to the most dangerous location imaginable, Zone 0. In the wiring rules, Zone 0 means you are literally submerged inside the water of a pool, spa, or fountain. Notice how drastically the safety limits drop here. We go from a 50-volt AC limit down to just 12 volts AC maximum. DC drops to just 30 volts. Any underwater lights or pumps must use SLV or PLV systems. Furthermore, the actual power source, the transformer, has to be physically located outside Zone 0, far away from the water. And here's the kicker. For SLV underwater luminaires, you are explicitly forbidden from running an earthing conductor into the water. The code assumes the water is highly conductive, so it engineers the situation to remove the voltage threat almost entirely.
Now, just to briefly contrast those tiny, touch-safe 12-volt underwater lights, Section 7 also acknowledges the total opposite extreme, high voltage. The very moment an installation exceeds 1,000 volts AC, the physics of electricity change completely. At these massive voltages, electricity can literally jump through the air as an arc. Because the dangers are so incredibly specialized, the wiring rules essentially step back and route these installations over to an entirely different standard, known as AS 2067. It's a fantastic example of how the codebook categorizes risk, knowing exactly when a specialized set of engineering principles needs to take the wheel. Which brings us to our final stop on the tour, engineering your safety. As we wrap up this explainer, let's connect all of this right back to your daily life. From the 50mm segregation rules keeping fire pumps alive in a burning building, to the manual isolation switches preventing your solar panels from electrocuting line workers, to the drastically reduced 12-volt limits inside your swimming pool, it is all part of a master plan. Section 7 of the wiring rules is the ultimate invisible shield, working constantly behind the plaster and concrete to engineer your safety. So I want to leave you with this final thought. The next time you walk into a large building and step into an elevator, take a look around. Ask yourself, is this just a standard passenger lift moving people between floors? Or is it a heavily armored, fire-rated safety service, wired up with WS classification cables, ready to serve as a vital lifeline the exact moment disaster strikes? The hidden, life-saving rulebook governing every switch you flip is always there, and honestly, understanding it makes the built environment around us endlessly fascinating. Thanks for learning with us on this explainer, and keep questioning the world around you.